Hey guys, it's Mrs. Harbin and we're doing video notes 5-2. Simple as ABC, figuring out the 5 types of reactions, deciding if they're what type you're looking at, use an activity series to see if a reaction will occur. Alright, so here we go. Please read chapter 6 and 7. Alright, and you'll learn about this. Okay, so there's 5 main types of reaction. One's called synthesis or combination, decomposition, single replacement, double replacement, or combustion. 5 types of reactions. We have a handful of them. Okay, so I'm going to show you how to figure out which is which. Synthesis is the same as combination, means the same thing. When things combine, they make one lot, right? One lot, combination lot. So we're going to look at our combination reactions as having 2 reactants and make one product total. Okay, in order to simplify it for chemistry, when we look at the 2 reactants, they should be an element. So element and an element is going to make a compound. Okay, so that's how we'll recognize synthesis reactions. We'll be looking for 2 elements to make one compound. All right, what's the opposite of that? Well, decomposition. Those zombies are going to decompose, and then their arms will start falling off. So one big zombie will make smaller pieces. So here's the words to describe it. A compound breaks apart into smaller pieces. We're going to have compounds that break apart into their elements when we predict the products. But anytime there's only one reactant, it's going to be a decomp reaction. Okay, so one reactant, element, element. One reactant, element, element. So a compound breaks up into elements to make a decomposition reaction. What about looking at samples, see if we can identify them? All right, this says nitrogen dioxide. Well, that's a compound, nitrogen dioxide. And then it says decomposes, key word, decomposes. Compound breaks down into smaller pieces. All right, so this is a decomp reaction. How do we recognize this one? Okay, calcium reacts with oxygen. This is an element and this is an element. So what type of reaction is this? Combination or synthesis. All right, because it's 2 elements reacting. This is a compound. How many reactants are there? There's only one reactant, so this is going to be a decomp reaction. Okay. This is 2 reactants. One's an element, the other one's an element, so this is going to be a combination or synthesis reaction. Whatever you want to say, combo or synthesis, no, it means the same thing. So 2 types of reactions so far, and they're opposites of each other, and you got to know what to look for. All right, what's the next kind of reaction? Single replacement. So it's kind of what happens if things are going wrong at the dance and you came by yourself and somebody came in a date with the date. If the one person kicks somebody out of a pair, that's a single replacement. You've been replaced. Okay, so in order to look at a single replacement reaction, you're going to have a single thing, which is an element, and it's reacting with a compound. So one element and one compound. And then what's going to happen is there's going to be a new compound and a new element formed. You have to use an activity series to decide if the reaction is going to work. Okay, and then the one that's more active wins. Okay, so the more active gets the girl or keeps the girl. That's the way it works. So here's a compound, here's an element. Apparently the element is more active because it kicked A out of the compound. Okay, so this is this is really J and B, Jen and Brad. And this is Angela, and Angela kicked Jen out. Anyway, it's all dramatic. But what you're looking for in a single replacement is a single thing element trying to kick out part of a compound. Talked about an activity series. Here we go. Here's an activity series. This is the activity of metals. Lithium is the most active metal on this list, and gold is the least active. There's also a non-metal activity series. Fluorine is most active. Astatine is least active. All right. Most active, least active. And that's the difference between non-metals and metals. So what kind of reaction is this? Well, we have an element and a compound. So we're thinking single replacement. You have to see if the element, the one by itself, is more active than what it's trying to kick out. So this is a metal. Metals can only replace metals. So this is a metal. So then we look, okay, potassium's right here, and it's more active than sodium. So anything that's more active or above can kick out. So potassium can go in and kick out sodium. So you're going to end up, sodium gets kicked to the curb, and then you're going to have potassium and chlorine combining to make KCl, 1 and 1. Okay. All right, so here's the element. It's a metal. Here's the compound. All right. So you have to see if the metal element can kick out the metal part of the compound. Is this element more active than aluminum? So here's tin, and here's aluminum. Guess what? Tin is not more active. Tin's less active. So aluminum can kick out tin, but tin cannot kick out aluminum. Not going to happen. So you could just write no reaction here. We'll practice this in class. All right. All right, so here's an element. Here's a compound. So bromine is a nonmetal. So you have to see, can bromine replace the nonmetal iodine? This is iodine. Okay. Can bromine replace iodine? Is bromine more active than iodine? Well, here's bromine. Here's iodine. Bromine can kick out iodine. So bromine can kick out iodine. So iodine gets kicked out. That leaves lithium and bromide to make LiBr, +1 -1. Iodine got kicked out, but iodine is the I in Nafkobrich, so it turns into I2. All right, so here's chlorine as an element. Here's sodium fluoride. That's the compound. Chlorine's the element by itself. Can it kick out fluorine? Is chlorine more active? Well, let's see. Here's chlorine, and it's under fluorine. So guess what? This is a no-go because the element has to be more active than what it's trying to replace. Okay, that's how you use activity series. Double replacement is when two compounds react. Two compounds react. Two compounds. And those compounds are going to have to be aqueous. All right, two compounds react. So the two compounds change partners. But everybody still gets a partner, don't worry. All right. Once something's in the front of a compound, it has to be in the front of every compound. So here's compound AB, compound CD. Look what happened. Compound AB, A and D make the new. So this is like soap opera chemistry, double replacement, square dancing. A's in front, but now it's with D. In this compound, C was in front, but now it's with B. Okay, it's the old switcheroo, double replacement, switcheroo, two compounds, switch partners. Okay, remember that the reactants are going to be aqueous, and there's going to be one solid product, or water, or gas. And we'll look at that when we predict the products. Okay. All right. So solubility rules will help us with ionic compounds, knowing what the solid is. So when we said double replacement, we're going to need a solid product. We're going to look for something that's not soluble, that doesn't dissolve. Okay. So here's some rules to use. AgBr, is it soluble or insoluble? Well, let's find silver on here. I don't see silver anywhere. Let's find bromide on here. Okay, bromides. Bromides will dissolve. Soluble means AQ. All right, soluble means AQ. Bromides will dissolve if they're with anything except if there was silver. So they do dissolve except with silver. If there's an exception, it's going to be solid, not dissolved. Okay, insoluble. Calcium sulfates. Let's see, if I can't find calcium on here, can I find sulfates? Sulfates. Sulfates are soluble, AQs, unless they're with sulfates with silver, mercury, or calcium. Oh, there's calcium, so that's going to be solid. It's not going to dissolve. Okay. NH4Cl. Okay, so let's look for ammonium on here. Oh, look, it's ammonium. Ammonium compounds are soluble. So we could put AQ there. All right. Let's look at barium nitrate. Barium nitrate. So let's look for barium. I don't see barium. Let's look for nitrates. Oh, nitrates. All right, nitrates are soluble. Okay, so that means anything with a nitrate in it will be aqueous or dissolved in water. Okay, we'll figure out the rest of those in class using solubility rules. Okay, a precipitate. What's a precipitate? So this is where those double replacements is where precipitates come into action. Okay, this is AQ, dissolved. This is solid. That yellow stuff is solid. So solid is a precipitate. It's insoluble. It's solid. You can put it down arrow or S for solid. Aqueous is dissolved in water, so it's soluble. So solid means not dissolved in water, meaning insoluble. And to decide if something is soluble or insoluble, you have to use those rules we just looked at. Okay, so here's some sample problems. Sample reactions. Sodium chloride, this is a compound, reacts with lead nitrate. That's a compound. Compound in a compound is a double replacement. Double R. Okay. All right. Oh, look, it's a compound and a compound. That's and you get two new compounds, and one of them's solid. So this is double R. Double R again. It's a compound and a compound. So that's going to be a double replacement. Okay. Potassium iodide is a compound. Reacts with aluminum nitrate as a compound. Compound plus compound is double replacement. That's how you decide what type it is. Last type of reaction we're going to talk about is combustion. Woo! Burn, 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 burn. In order to burn, there has to be oxygen gas. Okay. So when you're looking at the left side of the arrow, you're looking for oxygen gas and a hydrocarbon. What's a hydrocarbon? It's a compound with C's and H's. Sometimes they have O's in them. Okay. So any compound that has C's and H's in it is a hydrocarbon. Oxygen is O2. That's how you recognize a combustion reaction. What's cool about a combustion is the products are always going to be carbon dioxide and water. So right now this paper is burning. This paper made of C's and H's. And then it's burning with oxygen gas. And it's forming CO2 and H2O. Combustion reactions. So that's the fifth type. Alright, so we got to see all the types of reactions. You have to be able to identify them. So look at some samples. Hydrocarbon. Hydrocarbon. So we react with oxygen. This is combustion. How do you see a whole reaction? Hydrocarbon, oxygen, carbon dioxide, and water. Combustion again. Sugar burns. Hydrocarbon. Hydrocarbon. Alright. So plus O2. This is combustion. Make sure you can recognize these reactions. Alright. Oh look. We did this slide already. That was all double replacement. Alright. How do you ID the reactants? You look for a combination reaction. You look for two elements. Decomposition. You look for one reactant. Single replacement, element and compound. Double replacement, two compound. Combustion. Hydrocarbon and O2. So what are these? Let's see. Element, element. This is synthesis. Another word for that is combination. Okay. Compound, compound. This is double replacement. Element. I'm sorry. Compound, element. Compound, one element. But wait. Make sure if it's a compound and an element. If the compound has C's and H's, and the element's oxygen, then it's combustion. Combustion. Alright. Let's see. One single reactant, one reactant decomp. And finally, element, compound. This is going to be single replacement. How do I know? Element and compound, and it's not combustion. Alright, to review. This is what we're looking for. A little more Jackson 5. Make sure you can recognize all the types of reactions, whether you're given the whole thing or just part of it. Okay, so can you describe the 5 types, categorize the 5 types, use an activity series, and solubility rules. See you soon.